Hello everyone, it is great to be here. I hope you enjoyed the conference so far. My name is Koray Sözeri and I am game developer at POW Games. Today I will talk about design patterns and how to implement them into game development. How can we describe patterns? Design patterns are general solutions for problems frequently encountered in software and game development. They are like customizable templates for similar situations that are repeated many times. Although the contents of the challenges we encounter in software and game development are different, many of them contain structurally similar solutions. Design patterns are the solutions that software developers have come up with over time to solve these problems. From time to time, when you come across a design pattern whose content you do not know, yet you can think like, wait a minute, I applied it in a similar way before. A design pattern actually gives us a logic to overcome a certain situation. And there can be more than one implementation of this logic. Sometimes the situation we encounter may be more complex than the pattern presents. In this case, we can evolve the patterns while integrating and perhaps create our own pattern. Design patterns answers the question of how do I make the source code more readable and more maintainable. They help us establish relations between classes and interfaces. Design patterns prevent code duplications. They accelerate the development process by providing tested and proven solutions. Design patterns allow us to anticipate problems that may arise during development. Design patterns are a very useful assistant for software and game developers. Instead of memorizing classes and properties, we can control a project codebase by understanding how design patterns work. Design patterns are, in a way, a communication tool that allows developers to understand the code they have developed independently of each other. Every problem we encounter while developing a game may require a specific solution to that problem. The choice of which design pattern to apply in which situation depends on our requirements. The ability to apply patterns according to problems is also a skill that needs to be learned in order to reach a solution. Acquiring this skill can be achieved through practice by continually applying design patterns into game development. First, we need to define exactly the problem we are facing. Then we must determine which pattern will provide a better solution for this problem. We cannot directly import design patterns into projects, such as libraries and frameworks. Design patterns offer us a logic that we can apply by adapting it to the project we are working on. Although the purposes of providing solutions are similar, we cannot consider design patterns as algorithms. While the steps in algorithm are strictly defined, two different implementations of same design pattern can be very different. Design patterns are grouped into three main categories, as creational patterns, structural, and behavioral patterns. Creational patterns solve the object creation within the instantiator class itself, allowing the object to be obtained without exposing the object's creation logic. Thus, we encapsulate the context to the related classes and prevent overgrowing of the class that needs the object. Some examples of creational patterns we can use also in game development are dependency injection, factory, object pool, and singleton. In order to prevent the growth of the class in different scenarios and features, we use structural patterns to divide it into small modular parts to make it suitable for dynamic use and to switch between implementations in runtime. Behavioral patterns are concerned with how to make the most efficient communication between objects. I would like to explain some of these patterns in depth to demonstrate their actual usages in game development. I'd like to start with common pattern. Suppose we are developing a chess game. The player will probably want to undo his move in some steps. When we want to keep the usage of undo unlimited, we need a system to record every move. Here the common patterns comes in our aid. For the common pattern implementation, we define the piece moment in a separate class, and we keep every move of the player in a stack. Then when the player wants to undo at any time, we pull the last added value from the stack, where we hold the moment position and send the piece back to its last position. Next pattern I want to talk about is observer. While the actions we define while developing a game have a single visual output, it is likely that more than one process is taking place in the background. Let's consider a scenario where the player wins a reward after a certain progress. The output that the player will see will be gifts from a chest. In the background, too, there may be more than one layer processing this single output. The controller that manages data will add these gifts to the user's save file. Indicator panels in the UI will be updated. The class controlling the sounds can play a positive sound that makes the user feel he is doing something right. Maybe we can send an event to the Analytics SDK, indicating that the player is opened the chest. If I run all this in an imperative way and consider I'm doing this in hundreds of classes in the game's codebase, the references of all the classes that are affected by the actions will be found in hundreds of different places throughout the project, which will cause a code pollution, spaghetti code, and as a result, difficulties in managing the project, perhaps making the project even unmanageable. For example, if I define an event like onChess opponent on my chess class, all I have to do is subscribe the affected classes to this event. All chess class will do is to invoke the event when it is opened. It will not need to be aware of multiple layers such as data, UI, sound, and analytics. Next pattern I would like to talk about is state pattern. Let's say we are developing an artificial intelligence that responds to the player's actions. If the player is in the AI's field of view, the AI will follow the player. If it is close enough, it starts shooting, and it creates a new route when an obstacle comes between them. If we try to solve these conditions with if-else, we will end up with a chunk of code that is difficult to manage. Since we expect the artificial intelligence to react instantly, these controls will be made at any time. This will be the overuse of CPU unnecessarily and device charge. As a result, this could cause performance loss. Instead, if we express each of these conditions as a state of artificial intelligence and switch between states when necessarily, it will perform only the action of the current state. Then we could define states like patrol, follow, attack separately. Then all that needs to be done is specify the state and call set state when necessary. The last pattern I want to talk about is a pattern that I created due to the needs that emerged during our development process. It is called a sequence pattern. It's like an implementation of chain of responsibility, but works a little differently. While developing games, we may often need to run certain action in certain orders. A reward image travels to the appropriate panel. The user encounters an offer. A chest opens behind it. And sometimes a tutorial at only certain levels. The occurrence of these operations may depend on more than one condition, and sometimes they may not occur at all. If we make these controls for each possibility that may come after an operation, each class becomes a stack of code that contains more than one control. We use the sequence pattern to solve this problem in a manageable way. Sequence pattern works like this. First of all, we create an abstract operation class that each specific operation will derive and contain the basic properties of an operation. This class contains the initialize, start, and complete methods. At the same time, we create events that will be triggered at the beginning and complete of this process. Then we create a process sequence class where we will keep the reference of these processes and call the required methods when the turn comes. When this class is initialized, it will subscribe to the complete event of each operation class it contains. And when each complete event is triggered, it will call the start method of the next operation. Thus, operations will take place in order. In specific operation classes, it will be checked whether the operation will take place or not. And in case it does not, it will call the complete method, allowing the sequence to proceed to the next operation. Thank you for listening. I hope this switch will help you on your development journey. Do you have any questions? Thank you very much for listening.